Hello everybody, welcome back. Moving on with today's lesson. It is about arithmetic series. So we've already seen what an arithmetic sequence is all about, but what is a series? So there's kind of a demonstration here for you already. So over here on the left-hand side, that's an arithmetic sequence. So again, it's just a pattern of numbers, or there's some type of pattern happening to get to each and every single number in between. Looks like we're just adding 3 each time, right? So that's the actual sequence, but this is taking that sequence and putting it into a series. So it's really just the sum of the sequence. It's the same exact numbers. Now we're just taking those numbers and we're adding them all together. So again, that's exactly what an arithmetic series is. It's just going to be the sum of an arithmetic sequence. So just taking all those numbers in the sequence and then adding them up. That's it. We got a new formula though that we can also use. So right here, here's our new formula for the day. So to find the sum, you're just going to take basically the total number of terms, divide it by 2, and then inside parentheses, you're going to be multiplying n over 2 by the sum of the first term plus the last term. Okay, so everything still represents all the same stuff. So again, n is still the total number of terms in the sequence or in the series. A sub 1 is still going to be the first term. A sub n is still going to be the last term. S sub n is just going to be the sum. Okay? So for our examples, coming down to our first one, so how we read this, we know the first term's 12, we know the last term's 100, and there's 12 total terms in this series. Okay, so we only have 2 of them, so there's 10 other missing terms that we don't know what they are, but we could still find the sum, because we could just plug this all directly into our formula. So we're finding the sum of 12 total terms, so we're doing 12 over 2, and then inside we have a sub 1, which is 12, plus a sub n, which is 100. So you just plug it all in. Okay, now calculating, well, 12 over 2, that's just 6. And then adding 12 and 100, that's 112. And now we just need to simply multiply 6 times 112, and that should be 672. So although, again, we didn't really know those other numbers, we only had 2 of the 12 numbers altogether, you can still find the total sum. So 672. So number 2, same idea. We're finding the sum of 50 terms, 50 numbers. So when I plug this in, it'd be 50 over 2, and then a sub 1, the first term being 60, and the last term being negative 136. Okay, so it's all plugged in. So again, that's just 25, 50 over 2. 60 plus negative 136 is negative 76. And now we're just multiplying these two together. So the final sum comes out to negative 1900. And there you go. Looking at the next one. So let's see, we have a sub 1, we have a sub n, but then they randomly give you d. So what we're missing, we can't plug this all directly into the new formula because we don't know what n is. So from negative 8 down to negative 71, we don't know how many total terms there's going to be. Okay, you can find them because you know you're just subtracting 7 each time. But what you can do is you can use the other formula to actually solve for n. So the other formula being this from the sequences, a sub 1 or a sub n equals a sub 1 plus n minus 1 times d. Because again, we have a sub n, we have a sub 1, we have d, we just don't know what n is. So we could plug it all into the other formula to get n and then plug it into the new formula to then find the final sum. So there might be a little bit of flip-flopping in between these two formulas. Okay, but that's all right, we can manage. So plugging this all into the old formula, you'd have negative 71 equals negative 8 plus, so we don't know what n is, that's just going to be n minus 1 times d, which is negative 7. So going through and solving this for n, I'm going to do a little backwards distribution here. So negative 71 equals negative 8. That would be minus 7n plus 7. So we have negative 71 equals negative 7n. That would just be negative 1, negative 8 plus 7. Adding 1 to both sides is negative 70. And then dividing by negative 7, we're talking about 10 total terms altogether. So from negative 8 all the way down to negative 71, subtracting 7 each time, it's a total of 10 terms. Okay, so now plugging this all into the new formula, we're finding the sum of these 10 terms. So it'd be 10 over 2, and then a sub 1 again is negative 8, plus a sub n is negative 71. So this would just be 5 times negative 79, and that comes out to be negative 395 is the final sum. Okay, so pretty much the same idea for the next problem too. So if you look at it, you have a sub 1, you have n, and you have D. What we don't know is we don't know A sub n, so we can't plug it directly into the new formula to find the sum, but plug these three items into the old one. So we're solving for A sub n. We have A sub 1 is 42. We do have n, it'd be 8 minus 1 times D is 6. So A sub n is 42 plus, that's just obviously 7 times 6. So it'd be 42 plus another 42, which is 84. There's A sub n. Okay, so now take A sub n along with A sub 1 and n. We don't need D for this next step. Just plugging those three items into the final sum formula. So we're finding the sum of 8 terms altogether. So that's going to be 8 over 2. And then inside is 42 plus 84. So this is just going to be 4 times. So if I add those two together, that's 126. And then just simply multiplying, get 504 as your final sum. All right, there you go. So again, it's really just about using a new formula today. But again, you might have to do a little jumping in between the two formulas altogether. So different examples, different problems. It says to find the first three terms of each arithmetic series being described. So again, we just want the first three terms, right? Well, take a look at what you got so far. We have A sub 1, so we have the first term. So as we kind of fill this out, we want the first three terms, and the first term we know is 4. The very last term of this series is going to be 31. So it's not going to be the last term of these three. It's just the very last term of this total series. The total sum we know is 175. Okay, so what we obviously need is we have to know how are we getting to the next term. We have to know exactly how do I get to the next one after 4 and the next one after that value. So we need to figure out what D is. But based on what we have, we don't really have a choice. Since we have the sum, we're actually going to have to start with the sum formula. So let's plug this all into the sum formula and see where we're at. So we know 175 is the sum. We obviously don't know what n is. So it's just going to stay n over 2. And then we'd have 4 plus 31 inside. Okay, so we actually obviously have to solve for n first and then plug it into the other formula to now solve for D. Okay, so now just going through, solving for n, this would just be 175 equals n over 2. That's just 35, obviously, 4 plus 31. Next thing I would probably do is multiply both sides by 2. So that's what I'm going to do. Cancel that 2 in the bottom, multiply both sides by 2. So we have 350 equals, that'd be 35n. Dividing both sides by 35, we're talking 10 terms. So from 4 all the way down to 31, it's a total of 10 terms in this series. Okay, now take 10, along with a sub 1, along with a sub n. We don't need the sum anymore. Plug it into the other formula, and now we have to figure out what D is. So when you plug these three in, you'd have 31 for a sub n, 4 for a sub 1, plus n minus 1. So 10 minus 1 times D, so 31 equals 4 plus 9D. Subtracting 4 is 27, dividing by 9. All we have to do is add 3. So after 4, find the next two terms. So after 4, if I add 3, that's going to be 7, plus 3 comes out to be 10. There's our final answer. Okay, so doing the same thing it looks like for the next one. So let's see what we got. Again, we're starting with the sum. We have to plug it into the sum formula, but we have the last term and we have n. But we're still trying to find the first three terms of this series. Well, we don't even know the first term. We don't even have a sub 1 this time. So we actually have to solve for a sub 1 first using the sum formula and then plug it into the old formula to solve for D again. So plugging this all in, the sum formula, you'd have 760 equals 19 over 2. A sub 1 plus a sub n. There it is. Okay, so now going through, solving this now for a sub 1. What I'm going to do, I'm going to fix this. I'm going to rewrite 19 over 2. I'm just going to go ahead and write that as a decimal. So instead of distributing 19 over 2 to both terms, that's just going to create extra work for me. Again, write that as a decimal. That's going to be 9.5. Okay, now what I'm going to do, again, not even distributing 9.5, I'm going to divide both sides by 9.5. That's what I'm going to do. So again, if you distribute it, then it's just going to make it more complicated. But 760 divided by 9.5, then that comes out to be 80. And this is equal to, all we have left over here is a sub 1 plus 85. Now subtracting 5, you get negative 5 as a sub 1. So now we know the first term is negative 5. Okay, now plug this into the old formula. Now we have to figure out what is d. How am I going to get to the next two terms after that? So we need a sub 1. We don't need the sum anymore. We need a sub n, and we need n. So plugging this all into the old one, you'd have 85 equals negative 5 plus n minus 1. I'll just go ahead and write that as 18 times d. So two steps, just add 5, so that'd be 90. And then dividing by 18, you should get d equals 5. So to find the next two terms, just keep adding 5. So we got negative 5, 0, and then positive 5. And there you go. Okay, so let's move on to the next page. Find the sum, it says, of each arithmetic series. So if you're finding the sum, you're just trying to add up all these numbers, right? So again, you could use the formula. Okay, it's possible. So let's even kind of brainstorm. What do we have so far? So just by looking at problem 7, we obviously know the first term. We definitely know the last term, and we can figure out what the pattern is. Looks like we're subtracting 2. So d would be negative 2. So we can't plug it in directly into the sum formula because we don't know what n is. We don't know how many terms there are altogether in this series. We see 4 of them, but obviously that dot, dot, dot in between has some missing values. So there's some missing numbers here. Okay? So there's honestly one of two ways you could do this. So if you even think about it, excuse me, from 4 down to negative 10, that's not really a big jump. Okay? Honestly, what you could do is just fill in those missing numbers. Right? You don't really need the formulas. We already have 8, we have 6, we have 4. We know we're just subtracting 2. So what is left then? What is missing in between 4 all the way down to negative 10? So if I just keep subtracting 2, I'd have 2, 0, negative 2, negative 4, negative 6, negative 8, down to negative 10, right? That's where it stops. So now I can just add these all up together and see what it comes out to. But if you look closely, a lot of these actually cancel out. So like 2 plus negative 2, those cancel. 4 plus negative 4, 6 plus negative 6, 8 plus negative 8, all we have is 0 plus negative 10, which, guess what, that's just negative 10. Okay, so sometimes you could even just do that. You don't need formulas necessarily every single time. Just kind of think about, plan it out yourself and figure out, well, what's the easiest route to do this? Okay, so like number 8, for example, I probably would not do that because, well, from 28 to 112, doesn't really matter what we're adding by. That's kind of a big jump regardless. So I would not just fill in those missing terms. So I'm going to do this one using the formulas just to show you guys how it works. So again, we know the first term, we know the last term, and we can figure out what's happening here with d. Looks like we're increasing by 6. Okay, so obviously we don't know n. We don't know how many terms are altogether. Again, we see 4 of them, but all those missing terms have to also be accounted for. So what I'm going to do, I'm going to plug this all into the old formula, and I'm going to figure out what n is. So 112 equals 16 plus n minus 1 times d. Okay, so going through, solving for n, so 112 equals 16, 6n minus 6, so 112 equals 6n plus 10. Subtracting 10 is 102, and then dividing both sides by 6, this should come out to be n equals 17 in the end. So that's a lot of terms. 17 terms. Again, we only see 4 of them, so there's still 13 missing numbers in this series. So again, listing out all those numbers would be kind of a pain, I think, in this case. Okay, but now we need to find the final sum. So we got n, we got a sub 1, we've got a sub n, so now plug this into the sum of these 17 numbers. So that would be 17 over 2. And then inside we'd have 16 plus 112. So 17 over 2, that's just 8.5. And then adding those two together would be 128. So now just multiplying, the final sum should be 1088. 1088. Okay. So you kind of see both ways. Again, you could find those missing numbers, like I said, for the first one. I probably wouldn't do that for number 9. Number 9, I would probably use, again, the formulas, because that's a big jump from negative 37 to positive 35. Right, so that's a pretty big jump for that one. Number 10, though, this one's not too bad, going from negative 8 down to negative 20, because it looks like you're subtracting 3 each time. So kind of up to you on how you'd like to do that. All right, I want to get down to sigma notation, though. So these last problems, so I'm going to skip those two. I'll write down the final sum, so if you want to practice these on your own, the final sum for this one, you should get a negative 105 for that one. And the final sum for this one should be negative 77. Okay, but getting down to sigma notation, because this is the newer stuff. Okay, something you definitely have never seen before. Sigma notation, it's also called summation notation, so it just kind of depends on where you're looking at. Okay, so this is just the Greek letter, capital Greek letter, sigma. Okay, so how you read this, how I look at this. We're trying to find the sum, so I'm just reading the symbol first. You're trying to find the sum from the first term to the 10th term. So the first term is going to be a sub 1, and then the 10th term would be our last term. That would technically be our a sub n. And then how you find each individual term, how you figure out what is the first term, you just plug in, this is just a formula, 3n. Okay, so it even says formula for the terms of the series. So like I said, if you want to find the first term, you just plug in 1 for n. If I want to know the second term, well then I plug in 2 for n. If I want to find the 7th term, I plug in 7 for n, so on and so forth. Okay? So these are actually super easy. I know they look intimidating, they look kind of scary, but these are actually pretty easy overall. Okay, so looking at the first one, it says, so again, how I read this, it says you're trying to find the sum of the 5th term through the 8th term, and again, this is just the formula to find each individual term. Okay, so here's how I'm going to do it. Again, think about what you need to plug it into the sum formula. So I'll write it one more time. Here's the sum formula. So the 3 things we need is we need n, we need a sub 1, we need a sub n. You can find all 3 of those using sigma notation. Okay, so what am I doing? So I'm going to start with the first term. How do I find a sub 1? A sub 1 is technically going to be the 5th term. So we're only going from the 5th term to the 8th term. What you're going to do is you're going to plug in 5 for j. So a sub 1 is kind of more so like a sub 5. So a sub 5, again, technically is our first term, but if you just plug in 5 for j, you're doing 3 times 5 minus 4. So that's 15 minus 4. The first term is 11. Okay, so I got 1 down, 2 to go. Now I need the last term, a sub n, which is technically going to be a sub 8 in this case. So again, the 8th term is going to be the last term. We're only going from the 5th to the 8th term. So I plug in now 8 for j, so I'm doing 3 times 8 minus 4. So that would be 24 minus 4, and I get 20. All right, 2 down, 1 to go. I have the first term, I have the last term. And now I need to know how many terms am I talking. Again, I'm only going from 5 to 8. So how many terms is that? Well, the 5th term, the 6th term, the 7th term, the 8th term, that's actually going to be 4 terms altogether. So I know most of you might be looking at that thinking, well, why isn't it 3? Isn't 8 minus 5, isn't that 3? But again, you're adding each individual term. You're including the 5th term. You're including the 6th term, the 7th, the 8th term. It's going to be 4 terms altogether. Okay, so kind of a quick way to do it. If you do the whole subtraction, 8 minus 5, again, although that's 3, just add 1 more to it. So the total number of terms should actually be 4. Okay, so now we're just plugging this all into the sum formula. So we're finding the sum of these 4 terms. So 4 over 2. 11 plus 20 goes inside, so that's 2 times 31. The final sum would be 62. Now we're done. Okay, so let's do the next one, number 12. So same thing. We're finding the sum from the 3rd term to the 10th term. And again, this is just our formula, 2k plus 1. Okay, so let's find the first term, a sub 1, which again is technically a sub 3. The 3rd term is the first term. So I'm going to take 3, plug it in for k. So 2 times 3 plus 1, 6 plus 1, I get 7. Okay, now find the last term, a sub n, which is technically the 10th term. So taking 10, plug it in for k. We're doing 2 times 10 plus 1. So that's going to be 20 plus 1, 21. All right, 2 down, 1 more to go. How many terms are we talking here? So again, going from 3 to 10, how many terms is that? So if I do 10 minus 3, that's 7, but adding 1 more, that's 8 terms. Okay, now plug it all in, find the final sum. We're finding the sum of 8 total terms, which is 8 over 2, and then we'd have 7 plus 21. So that's going to be 4 times 28. So our final answer comes out to be 112. Would be the final sum. Okay, let's go through the next 2, last ones. Number 13, so we're finding the sum from the 2nd term to the 10th. And again, we got our formula, so starting with the first term, which is technically a sub 2, So 2 goes in for j. So 4 times 2 plus 1, 8 plus 1, and you get 9. Okay, next one. Plug in now 10 for j. So we're finding the last term, which again is technically the 10th term. So doing 4 times 10 plus 1, which is going to be 40 plus 1, and that's going to be 41. There you go. Last thing now, how many terms are we talking? So what's n going to be? So again, going from 2 to 10, well, 10 minus 2, that's 8, but plus 1 more, that's 9. Okay, so now plug it all in. Final formula. We're finding the sum of 9 terms, so 9 over 2, and then we have 9 plus 41. So that's going to be 4.5 times 50, and that comes out to 225 as the final sum. All right, last and final. So we're finding the sum from the 3rd term to the 12th term. Again, here's our formula. So if I want the first term, which is technically the 3rd term, take 3, plug it in. So 4 minus 3 times 3. So 4 minus 9, that's negative 5. Now find the last term, which is going to be the 12th term in this case. So 12 goes in. 4 minus 3 times 12. So that's 4 minus 36, and that's negative 32. Okay, now find n. How many total terms are we talking? From 3 to 12. Well, again, 12 minus 3, that's 9. Plus 1 more, though, n would be 10. So now find the final sum. So plugging this all into the final sum formula should come out to be negative 189, or 85, sorry. Negative 185 would be your final answer. All right, well, that's it, guys. Hopefully you enjoyed this lesson. Feel like you got something out of it. Let us know if you have any questions, but otherwise, have a great day.